So, number systems. So we start with our natural numbers. So I've written them on a plastic bag. I hope this works. So we have our natural numbers, and you'll see we've got our funky N sign for natural numbers. Now, if we do operations on these numbers, like adding and subtracting and multiplying and dividing, if we add two natural numbers, say the 2 plus the 3, we get a 5, which is another natural number, so that's 5. There's an issue though if we subtract. So say we take the 3 and subtract 3. Then we get 0, and 0 is not a natural number. So we need another number. We need 0. So if we introduce 0 in addition to the, see if I can arrange my plastic bag like that, okay. If we add our 0, we now have a new set of numbers, which includes the old set. Now we have what are known as the whole numbers, and here's our sign for the whole numbers, n with a little 0. So there we go. Now we're fine, but say we subtract. So say we take 3, take away 2, that's fine, it's 1, it's a natural number and a counting number, or a whole number, so that's fine. But if you do 2 take away 3, you're going to get -1, which is not in our set of whole numbers. So we need our negative numbers now. So now I need to add another box, or put these inside another box, whoops, to get another set, which includes the other two sets. And now we have our integers. And now we seem to be fine. If we add and subtract an integer, we'll get another integer. And if we multiply, we get another integer. The problem is if we divide. So if you take the 2 and divide by 3, 2/3 is not an integer. So now we need those fractions which are not integers. So now we need to put these boxes inside another box. Okay, let me see if I can arrange that. Okay, whoa. Not bad, you got the idea. Now we have the set of rational numbers. So everything in that yellow rectangle is a rational number. Some of the rational numbers are integers. Some of the rational numbers are not integers. So now we're fine. Now, there are some numbers which cannot be expressed as a fraction. A rational number is expressed as can be expressed as a fraction. So there are these numbers. Let me see if I can add them here like that. There you go. There are these numbers like the square root of 2, the cube root of 7. These numbers are not rational. They are irrational. And we have a symbol for irrationals, a Q with a line on the top. The symbol for rationals, if you can see up here, is a Q. So if we want to kind of negate that, we'll put a line above it and say these are not rational, irrational. Now all of these numbers together make the real numbers. And just down the bottom here you can see the big R, which is the symbol we use for real numbers. So here is a quick summary of the number systems. We start with the natural numbers, that's the symbol. Natural numbers, numbers 1, 2, 3, 4, 5, and so on and so on and so on. If you add a 0 to the natural numbers, we get the whole numbers. There's your symbol. If you add the negative whole numbers, we now have the integers. There's your symbol, the funky Z. So the integers are all from, goodness knows, negative infinity. All the way to 0 and then on to infinity, but they are whole numbers. Those are the integers. Rational numbers, a Q, all the fractions. So you've got common fractions, negative decimal fractions, recurring fractions. This is, what do you call this? I suppose it's a mixed fraction, and so on. Not all, well, just remember here that a number like 2 will be rational because you can write 2 as 2 over 1, I suppose, or 4 over 2, so be careful. A number like the square root of 25 is 5. So 5 will be a rational because it's 5 over 1. It's also an integer, it's a whole number, and it's a natural number. Irrational numbers. Not every number can be expressed as a fraction. So numbers like you've got here, cube root of 101, pi, negative root 7, root 2, these are not fractions, they are irrational numbers. And all of these numbers together make the real numbers. So to finish this video, I want you to copy and complete this table where you will classify numbers according to the sets we've talked about. So let me do the first one for you just to give you an idea, then it's over to you. So take a half. So is half a natural number? No. Is it a whole number? No. Is it an integer? No. Is it a rational number? Yes. Therefore it cannot be irrational, but it'll be a real number. Okay. So, stop the video, you complete the table, and then when you're ready start me up again and we'll check if your solution is the same as mine. Right, here we go. Negative 2, no, it's not a natural number. No, it's not a whole number. Yes, it is an integer. Yes, it is rational because it can be a fraction, negative 4 over 2, for example, negative 2 over 1. Therefore it cannot be irrational, and it will be a real number. 20 is a natural number. It's a whole number. It's an integer. It's rational, therefore it's not irrational, and it'll be real. Square root of 5. Nope. Not a whole number. It's not a fraction. It's not, it's not an integer. It's not fraction. Therefore it's irrational, and it's real. 0. No, it's not a natural number, but it is a whole number. So it must be an integer, and it must be rational, so it cannot be irrational, and it's real. 7. Yes, 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 no, yes. Root 9, oh, be careful, root 9 is 3. So, yes, it is natural. Yes, it's a whole number. Yes, it's an integer. Yes, it's rational. So, no, yes. 1,3. No. It's not a whole number. It's not an integer. But it is rational, because it's a fraction. It's a decimal fraction. So, therefore, as it's rational, it cannot be irrational, and it's real. Okay, so I hope you're a little bit better at numbers and what set they belong to.